Hello, my dear students. So last session, I think we have solved the problems on node analysis and mesh analysis. And till 11th problem we finished, and let's go with now 12th problem. Okay. So the 12th problem is given like this. Find what is that? Read that question. V1, V2 and V3. Okay. And what else is asking? Power of each source. Power supplied or absorbed by each source. Power supplied or absorbed by each source. Okay. So now look at the question here. You draw it again, all of you. You can draw it. You can draw it again, all of you. This is 12 volt, 20 volt, 10 volt, 4 milliampere, 10 kilo ohm. Okay. So he's asking what is V1, V2, V3. Okay. What is V1, V2, V3? Okay. So look at the problem. First of all, if you go for mesh analysis, 1, 2, 3, 3 minus 1, 2 equations required. If you go for node analysis, 1, 2, 3, 4, don't come to 4 minus 1 conclusion, because already you have 3 energy sources which are not having any series resistor. And not only that, but all these 3 sources are sharing a common node which do not have a series resistor. Yes or no? Now you already know that if this is taken 0, this voltage will definitely appear here. Yes or no? Therefore what will happen? V2 will become what? 12. Now jump from this point to this point. Because there is no resistor, you can jump directly because you know the voltage here. 12 minus 10 will become what? 2, because you are jumping from higher potential to lower potential. Drop the voltage. Jumping from higher potential to lower potential, drop the voltage. 12 minus 20 minus 8. That means you already know the number of equations required to analyze this network. Minimum number of equations is 0, and that you can achieve only through node analysis. Yes or no? Okay. So let us look at now the V1, V2, V3 values, whatever we found here, V1, V2, V3. What is V1 now? V1 is equal to, okay, 12 volt. And what is V2? V2 is equal to 12 minus 10, right? Jumping from higher potential to lower potential. What is that? 2 volts. Okay, jumping from higher potential to lower potential. What is V3? V3 is equal to 12 minus 20. What is this? Minus 8 volts. Okay. So you got this now. Now let us look at the power of each source. Power supplied or absorbed by each element is asking. I mean, each energy source is asking. So I think you understand what is the power of the 4 milliampere. Yes or no? What is the power of 4 milliampere here? V1 into 4. Yes or no? V1 into 4. What is V1 already you got here? Okay. What is V1? It's not V1 actually here. It is V2, right? This is V2. This is V2. And this is V1, right? So what is V1? Because V2 is directly 12 volts. Jumping from here to here, you are getting V1 value, that is 2 volts. So therefore, 2 into 4, 8 milliwatt. 8 milliwatt. Now what is this current doing actually here? Plus minus, current is leaving from positive terminal, that is nothing but what? Supplied power. Okay. Now coming to another source here, another source, 10 volt, then 20, then 12. Let us see one after other. Power of 10 volts, let us see now. What is the procedure? Power of voltage source, if you want to find, you must know current through voltage source. But what is the current through any element or current through any path? What is the procedure? In that path, if there is a resistor, then you can apply Ohm's law. Otherwise, go for KCL. There is no resistor, therefore, let us apply Kirchhoff's current law either at this node or at this node to find the current in this particular path. I cannot apply here because I do not know 20 and 12. I do not know the currents. The same scenario I am having here. Therefore, I do not know. Let me apply Kirchhoff's current law here. For that, let me assume some current. Assume some current Ix. Let me assume it. Okay. What will happen if you assume here? Then you can take on what basis you are putting the direction here. Not based on these polarities, my dear friends. Okay. Not based on these polarities. I'm just taking randomly. Let me see what will happen. My assumption is correct or not. I will see later after finding that Ix value. If I get positive, my assumption is correct. If I don't get positive, that means I get negative, then my assumption is wrong. But my approach is correct. Okay. So let me apply Kirchhoff's current law at this node. Okay. KCL at node A. KCL at node A. Ix is leaving. 4 milliamperes is entering. Now what about the current flowing through this particular path? V1 minus V3 by 5. That is leaving. V1 minus V3 by 5. 4 plus, what is V1? 2. What is V3? Minus 8. V1 minus V3, 2 minus of minus 8 plus 10 by 5. Finally you got, okay, this is this 2ja, okay. See this, 4 is entering, okay, 4 is entering actually here, and Ix is leaving, V1 minus V3 by 5 is leaving. But you have done a mistake here that 4 is entering, but this one is leaving, right? So therefore you can write minus, or else you can write that, you can put like this, that sum of leaving, that is Ix is leaving, and 4 is what is it doing actually? Entering. Therefore you can put like this if you want. Then Ix, then this is 4 actually here, right? Therefore, what do you get here? Ix is equal to 4 minus 2 milliampere. You understand all of you, okay? Look at this. 4 is entering, Ix is leaving, V1 minus V3 by 5 is also leaving. Sum of leaving is equal to sum of entering. This is already how much here? 2 minus of minus 8, that is 10. 10 by 5 is 2. Ix plus 2 is equal to 4. Finally, Ix is equal to what? 2 milliamperes. Then what is the power? The power of 10 volts will become 10 into 2, that is 20 milliwatt. But what is this current doing actually here? Current is entering into negative, nothing but leaving from positive. Therefore, I can take it as supplied power. Then power of 20 volt. Power of 20 volts. What is the power of 20 volt? Power of 20 volts means again you need to find the current here. Assume some current, take random directions. Take some current here, IY, nothing wrong in this. You can take this way or this way. Let's see what will happen. Okay. Apply KCL either at this node or at this node. KCL at node B. Okay. KCL at node B. Let us apply KCL at node B. KCL at node B. Okay. Now, what is IY doing? IY is entering. V3 by 10 is leaving. Okay. Now, V1 minus V3 by 5 is entering for this node, leaving for this node, but entering for this node. Or else you can take V3 minus V1 by 5. That also okay. Okay. That is also okay, right? V3 minus V1 by 5. V3 by 10 is leaving. V3 minus V1 by 5 is also leaving, but IY is entering as far as node B is concerned, right? Therefore, what is this? Actually, V3 means minus 8 by 10. What is V3 minus V1? Minus 8 minus 2. Minus 8 minus 2, that is minus 10. Okay? Minus 10 by 5. Okay? Minus 10 by 5. This 2ja. Minus 2.8. Look at this. Minus 2.8. I got a negative value. It means that my assumption is wrong. No problem. It means that if I had taken in the reverse direction, then I would have got positive value. That is the meaning of it. Okay, so do not worry about that. So what is the power finally here? Power of 20 volts will become, okay, minus 2.8 into 20, that is minus 56 watt. Okay, minus 56 watt. Current is entering into positive, therefore it is absorbed power. Okay, plus 56 watt supplied power. Understand? Okay. Now, next one. Power of 12 volts. Power of 12 volts. Power of 12 volts. Okay. Again, you need to find the current here. Of course, if you know Ix, then Iy, then you obviously know the current in this. Yes or no? By applying Kirchhoff's current law here. But I'm just trying to, okay, trying to apply the KCL once again here for the sake of practice, treating this one as an independent calculation. Okay. So let me assume some Iz. Without knowing Ix, Iy, I must be in a position to find Iz. Yes or no? Okay. Therefore, let me apply Kirchhoff's current law at this node. I can apply here, but if I do not know Ix, Iy, I cannot apply here. Okay. But I can apply here without knowing Ix, Iy, because I know current here. I know current here, V3 by 10, right? So therefore, what is the current actually here? KCL. Okay. KCL at node C. Then what is actually Iz? Iz is the leaving current, yes or no? Then V3 by 10 is an entering current, 4 is a leaving current, yes or no? Then what is this actually here? V3 is nothing but what? Minus 8. V3 is minus 8, that is minus 0.8. Then Iz will become what? Iz will become minus 4.8 milliamperes. Now tell me, power of 12 volts will become minus 4.8 into 12. Okay. Then you have, find these values. Okay. So please note down all these things, all of you. You can go with this and 4.8 into 12. 4.8 into 12. All of you start noting down this. I'm just calculating this value. Okay. 57.6 minus. 57.6 minus, that is supplied power. So you got still negative value. That means your assumption is not correct. Okay. So don't worry about that. You can convert now this into positive value, plus 57.6 milliwatt, that is absorbed power. Okay. So please note down. I think all of you understand how we are calculating all these things. Okay. So please note down. So these currents are very, very important to find the powers. In exam, you will get any one of these. Okay, he will ask you not all these things, but we have a good practice in finding the powers of each source. A source which doesn't have a series resistor, voltage source. And for that, when you want current or power, the procedure is same. When there is no resistor, apply KCL to find the current. Obviously, if you know current, you know the power. Okay, so this is very, very important calculation. These three are very, very important calculations. Okay. Thirteenth problem. Problem number 13. Okay. .25 ohm, 0.2 V1, 10 ohm, 25 ampere, 100 ohm. All of you draw it again. So the question is, find I1, I2, I3 and I4. Okay. And dependent variable is shown here, plus, minus. Okay. Whenever a network is given, remember all of you, your focus must be always on how to solve it. When you want to solve it, you have only two options. What are they? Number one is the mesh analysis, the other is what? Node analysis. That's it. Now you just check how many equations are you getting using mesh and how many equations you are getting using node analysis. Simple, there ends the matter. Honestly, don't break your head, okay, and don't discover any other method, okay. Instead of discovering the new methods, better you follow simply either mesh or node. I'm sure that you'll get the answer. Otherwise, I'm telling you, you're going to waste your valuable time in the exam, okay. So look at this now. How many loops are there? Can you tell me how many loops are there? How many loops? 1, 2, 3, 4. Okay. 4 loop currents plus 1 dependent variable. So how many equations you get when you go for mesh analysis? 5 equations. Do you think that the person who designed the problem is expecting from you that you need to solve 5 equations? No. Yes or no? Nobody will give a problem with the 5 equations. So never choose the mesh analysis here and never try to get the relations between I1, I2, I3, I4 and V1. Never try, because if you start trying getting the equations in terms of I1, I2, I3, I4, then I'm sure that you need to go for 5 equations. Yes or no? So you'll be in trouble definitely. Instead of that, when mesh analysis is not working out, what is the next alternative approach you have? Node analysis. So let's go for node analysis. Let us see how many nodes are there. 1, 2, 3, 4, 5, 6, it looks like. Yes or no? It looks like. But look at this. This point and this point both are operating at same potentials. And this point and this point both are operating at same potentials. That means if I give numbering 1, then this is going to be 1. If this is 1, this is also going to be 1. Yes or no? This is 2, let us say if I assume, then this is also going to be 2. If this is 2, this is also going to be 2. Then finally how many nodes are there? Just only 2 nodes. If one node is selected as a reference node, then one equation is enough. Yes or no? Because of the dependent variable, there is a possibility of getting extra equation. But if you select the second node as a reference node, this voltage will become what? V1. Yes or no, all of you? Now, people may understand clearly after taking 1, 2, 1, 2 and all. Look at this. This element is between what? 1 and 2. This element is also between what? 2 and 1. Or 1 and 2 both are same. This element is between 1 and 2. 1 and 2, 1 and 2. All elements are sharing common pair of nodes. What does it mean? When all elements are sharing common pair of nodes, it looks like this. Look at this, all of you. They are in parallel. Yes or no? When all elements are connected between two nodes or sharing common pair of nodes, okay, if this is 1, then this is 2, then look at this, this direction is towards 1, right? Okay, then between 1 and 2, okay, between 1 and 2 and towards 2, between 1 and 2, Okay, this is 100 ohm and this is 25 ampere and this is 10 ohm. This is 0.2 V1. What is this? This is 25 ohm. Okay, so it is proven that all elements are connected in parallel. Now what is actually here the voltage between 1, 2, this is plus, this is minus, V1 is given. Understand? But even without drawing this figure, you must be in a position to understand that they are in parallel and you can solve it directly. Why should we draw it unnecessarily? The way time waste process here, yes or no? But still, to make it very clear to all of you, okay, some of you might have not realized that they are in parallel. To make you understand, I have just drawn and proven that they are all in parallel, okay? And the directions are very carefully placed here, 1, 2. The dependent source is towards 1, the independent source is towards 2, the direction. That is why I placed downward towards 2, towards 1. Clear all of you? Okay. Now, let us apply the node analysis. If it is 0, then this is going to be what? V, but already this is V1. So let me take V1. Now, dependent variable and node variable both are same. Extra equation requirement is also not there. Yes or no, all of you? Okay. Now, what is that actually you are going to get? Okay. Instead of applying here also you can apply. Look at this. I'm applying KCL here at node 1. V1 minus 0 by 25. It's not over, right? Again come here. Now minus 0.2 V1. Now again here. V1 minus 0. What is this voltage actually here? If this is 0, this is also 0, right? V1 minus 0 by 10. It's not over still. Now again come here. Now plus 25. Then V1 minus 0 by 100. So this is how you apply the node analysis. The same thing you can see here. Okay, V1 by 25 minus 0.2 V1. V1 by 10 plus 25. V1 by 100. But without looking at this diagram, can't we apply node analysis here itself? If you realize that all elements are in parallel and what are the elements connected to node 1? How many elements are connected to node 1? 1. Not only this. 2, 3. Not only this. 4, 5. Clear all of you? Okay. Now, let me apply. V1 by 25. My objective is not looking at this. Directly I want to solve it. I have drawn that only to make you understand in a more clear way. Okay. So V1 by 25. Then minus 0.2 V1. Then what is this? V1 minus 0 by 10, right? V1 by 10. Then coming here plus 25 plus V1 by 100 is equal to 0. That's it. One equation, one variable. If you solve it, okay, you get 500 volts. Please do that. I think you have calculators with you. You can take common V1 and you can simplify it. You will understand that the value is 500 volts. Understand all of you? Okay. Now, once you get these 500 volts, now what is our objective actually here? I1, I2, I3, I4. Okay. Here also you can indicate what is I1, I2, I3, I4. Yes or no, all of you? What is I1 actually here? This is what? I1. Look at this current flowing through 25 ohm. What is I4? I4 is here. In which direction it is flowing? Actually towards 1. This is what? I4. Understood all of you? Okay. What is I2? I2 is, this is the point where 0.2 V1 and 10 connected. This is the point where 0.2 V1 and 10 connected. Okay. And this is a point where 25 and 100 connected. Where is that? 25 and 100 connected. This is the point. This is the point. In between these, the current flowing here is I2. You understand? Okay. Now, I3. What is I3 actually here? Where is this wire? You have to identify that wire in this particular combination. 25 and 0.2 V1. Where is it? 25 and 0.2 V1. Here. 25 and 0.2 V1. Here. Okay. Now, what about this? 10 and 25 connected. 10 and 25 connected here. Now, between these, there is a wire and the current is how much here? I3. Like this. So, definitely, there is a complication involved. Restructuring the network, redrawing the network, identify I1, I2, I3, I4 is also a complicated procedure. That's why I generally don't draw this. I directly attack the problem from here itself. Okay. Now, okay, look at this now. Let us always look at this problem. I1. What is I1? How do you find I1? I1 is the current flowing through this path. Tell me what is the procedure to find current through a path. If that path is having a resistor, Ohm's law, otherwise KCL. Is it having any resistor here? Yes, there is a resistor. Yes or no? Why don't you come to this extent? If you come to this extent, it is very clear that they are in series in the same line they are having. Therefore, current through 25 is nothing but current through this path only. I can write that I1 is equal to, okay, V1 by 25. But because of this polarity, the current is flowing in this direction. V1 by 25 expression will give you this direction. But you want in the reverse direction. Mismatch is there. Minus V1 by 25. So, what do you get? Minus 20 ampere. Now, I want I2. I2 means what here? The current through this particular path. Does it have any resistor? No. Don't say this is a resistor in this path. No. There is one more element connected here. Now this zero resistance wire and this 100, they are not in the same line. You understand, all of you? They are not in the same line. Okay? They are not in series actually. So you cannot say I2 is the current flowing through 100 ohm. It's not possible because there is one more element connected here. So when there is no resistor, obviously we go for what? KCL. KCL at node A. KCL at node A. KCL at node A. Tell me. How do you get? Either you apply KCL here or here. Doesn't matter. Anywhere is okay. Let me apply here. Now I2 is what is doing? Entering. As far as this node is concerned, I2 is entering. 25 is leaving. Then what is the current flowing here? Where is this V1 operating? V1. Where is this 2 is operating? 0, right? So V1 minus 0 by 100. The current will give you. This is nothing but V1 only. Okay. So V1 by 100 leaves. 25 leaves. I2 enters. Sum of entering is equal to sum of leaving. So plus 25 plus V1 by 100. So obviously this is 500 by 100, 25. Then this is 30 ampere. Okay. Then now I3. How do you find I3 here? I3, what is the procedure to find current? No resistor here. Don't say this is a resistor in this path. No. This is the resistor in this path. But this is not the resistor in this path. There is one more element connected here. Yes or no? Okay. Therefore, now you can see the current is leaving. V1 by 25 is entering. 0.2 V1 is leaving. Now sum of leaving, sum of entering, you must write. Better you apply Kirchhoff's current law at this node. Okay. Or else you can apply here. But let me apply here. It looks very simple for me. Then KCL at node B. KCL at node B. Now I3 is leaving. Okay. I3 is leaving. 0.2 V1 is leaving. Yes. 0.2 V1 is equal to V1 by 25 is entering. V1 by 25 is entering. Okay. So you already know that 0.2 into 100. What is that? So 0.2 into 500 is nothing but 100. V1 by 25 is nothing but 20. So finally you get this I3 is nothing but minus 80 ampere. Yes or no? This is 20. This is 100. Therefore minus 80. Next. I4. What is that I4? Tell me. What is that I4? Is there any resistor in this path? Please extend. Understand what is the degree here? 2. Wherever you have degree 2, okay, it indicates that elements are in series. Zero resistance wire, if you treat as one element, 0 ohm, and this 100 ohm, in between there is a node, that node degree is 2. That means they are in series. Yes or no? Wherever you have degree 2, they are in series. Here degree 2, okay, this is 0 ohm, let us say, then degree 2, these two are in series. But this is degree 3. That is why 25 and 0, they are not in series. Therefore, current here and current here both are different. Understand? Okay. So I4. What is I4? Current flowing here is nothing but current through 100 ohm. But what is voltage across this 100 ohm? Is V1 only. Because 1 is operating at V1 and 2 is operating at 0. So V1 by 100, the direction is this way. But you want in opposite direction. Therefore, minus V1 by 100. Minus 5 ampere. Okay, this is how you are supposed to analyze the networks. Very good problem, this one. You have to attempt the same problem multiple times to get the command over that. Okay, so please do that. Solve it, all of you, complete it. Complete it. So whenever you have zero resistance wires, it is always an advantage for you, remember. Okay, zero resistance wires are there, then it's an advantage for you. Simply apply the numbering technique. 1, then 1, 2, then 2. If this is 1, this is also 1. If this is 2, this is also 2, because all these nodes are operating at same potentials. All these three nodes are operating at same potentials. This is between 1 and 2, 1 and 2, 1 and 2, 1 and 2, 1 and 2. All elements are sharing common pair of nodes. That itself shows that they are in parallel. There is no need to construct. I have constructed that only to make you understand clearly. And next time onwards, I am telling you, when you come across this kind of networks, without redrawing the network, you must be in a position to do it. But if you still have any kind of confusion, then better you draw it. I advise you definitely to draw it. If you have any, if you feel that there is a confusion, because ultimately answer is important for us. Okay? Good. So I think we have done with this, right? All of you. 14th problem. We'll start with 14th problem. So this was asked in GATE actually. Please redraw the network again in your notebook. Classroom workbook 14th problem. Fourteen, 1 ohm, 2 ohm, 40 volts, 100 volts, 10 ampere, 5 ampere. Okay. Then what is the question actually is asking? The value of R. There are 4 options given, right? 10 ohm, 18 ohm, 24 ohm, 12 ohm. Okay, I think all of you are having that worksheet with you. Please open that worksheet, classroom workbook. Let us solve it. Okay. Now, how do you solve the network? First of all, look at that. What is the data given? What is the data given? There are different ways, definitely. Not a single way you can say, but there are different ways. Look at this. First, let us understand what do we need basically. Look at this. We want R, right? That means we require current and voltage. So that this voltage by this current will give us what? Resistance, yes or no? So this is VR, let us say. This is IR, let us say. VR by IR will give you R, that's it. Okay. Now, if you take this 0, because node analysis is always the best method because there are 2 ideal voltage sources connected here. Then if you take it 0, then obviously you know what this is? 40 volt. What about this? 100 volt. Now 100 minus 40 will give you what? VR. Therefore VR is equal to 100 minus 40, 60 volts, you got it. Now only thing you need to find current. Remember all of you here, to find this current, look at this all of you, to find this current, since you know the current is already given, if you know current here, I think you can find the current. Yes or no? Or else, since the current is given here, If you know current here, you can find the current here. Yes or no? Anything is okay, either this side or this side. Let me choose this side. Okay. If I know the current here, because I know the current here, I can find the current here. But to know the current here, you must know the current voltage at this particular node. For that, let us find V minus 100 by 14, V minus 40 by 1, V by 2. Okay. Therefore, you can find the V value. So, V of inspection 1 by 14, 1 by 1, 1 by 2, okay, 1 by 1, 1 by 14, 1 by 2, yes or no, okay, then is equal to 100 by 14 plus 40 by 1 plus 40 by 1. Then find the value of V, simple, then find the value of V, okay. So just solve it and you can get the value of V here, okay. Definitely you get 30 volts here. 30 volts. Now once you know this V, you can find IR, okay, I through 14, right? I through 14. Then what is this 100 minus V by 14? 70 by 14, that is 5 amperes. Therefore, IR value will be, if you apply Kirchhoff's current law here, 10, 5 leaving, the remaining current is flowing here. 10 minus 5 is nothing but 5 ampere. Then R value is nothing but VR by IR, okay, then 30 by, sorry, this is 60, right? So 60 by 5, this is 12 ohm. Understand all of you? This is one way. You can think like this, or else, let me draw the network once again here. See, let us try to see all possible ways, okay, which will help you a lot in analyzing different varieties of networks. Even at difficult situations, you can get some ideas, spontaneous ideas you will get when you see all different possible ways, okay. R and 14 ohm, and this is 1 ohm, this is 100 volt, and what about this? This is 40 volt, this is 2 ohm, and this is what, 5 ampere. Here it is how much? 10 ampere. Okay. Now he's asking this. You already know that the voltage across this one is how much, because you have taken this one 0. You have got this voltage how much here? 60 volt. Yes or no? Because this is 100 volts and this is 40 volts, and finally 100 minus 40 will give you plus minus polarity 60 volt. Now let's find the current in this. To find the current, you must know current here. To know the current here, you must know voltage here. But this voltage V can be determined because here it is 10 ampere. That means here it is how much? 10 amperes. Here it is 5 ampere. That means here it is 5 amperes. Total 10 plus 5, 15 leaving. Then how much should enter? 15 should enter. Okay. Yes or no? To satisfy KCL. 15 into 2. What is this now? 30 volts. Yes or no? Then you obviously know what is V. V is nothing but 30 volts. Now once you know V, what is current through 14 ohm? This you already know here. The same procedure now you continue here. Once you know this, okay, the same procedure you can continue. This won't change, but in finding V, there is no need to apply node analysis. Since already current is given here, this is also given here. Now the total current through 2 ohm is known. 2 into 15, 30. And since the direction is downward, it will decide the polarity is plus minus. Then obviously you know how much here? 30 volts. That's it. This is also a way to analyze the network. Okay. For this problem particularly, you don't need to apply node analysis. Okay. Do it quickly. Note down that. Meanwhile, I just give you one more. Okay. Question number 15, I'm just noting down. First you note down all these things. I'm just meanwhile giving you one problem here. Classroom workbook, question number 15. Question number 15. This is also asked in GATE. Okay. So read the question number 15. I think you have done with this, all of you. Question number 15. Read that. Question number 15. What is asking? In the circuit shown in the following figure, the value of I is given by. Some options were given. Okay. I think in the last question, 12 ohm is the correct answer, right? So option, what was it? D. Option D was correct, right? 4 options were given. Option D was correct. Now look at this. There are also some options were given. 0.31 ampere, 1.25 ampere, 1.75 ampere, 2.5 ampere. Okay. Let us look at the dependent source problem. Okay. Now, what do you get here? I is equal to, you can write directly I is equal to, let me change the pen. Okay, I is equal to, what is I? 4 VAB by, yes or no? 1 plus 3. Okay, these two are independent loops, yes or no? Can you expect any current here? No current is passing here because there is no written path. What is the current here? 0 ampere. Then what is the current that should come here? Also 0. Either this direction doesn't. 0 means what? Anything is okay direction. If you say this is 0 because the open circuit, no current you expect, then you can't expect any current. But suppose if you connect, okay, any element here, definitely you can expect some current. You understand, all of you? Okay. If you connect like this, then you can expect some current here. If you connect like this, you can expect some current here. Following all of you, okay? Then here I is equal to 4 VAB by 4. Then finally it is nothing but VAB. Equation 1. I is equal to VAB is one equation, but I must solve it with another equation, definitely. But can we find what is VAB here? A to B you can travel and use the touching concept and get the value. VAB is nothing but potential difference. Potential difference anywhere in the circuit using KVL or touching concept, both are same. So VAB is equal to, what is the voltage division after that you get here? This is 2.5 volts. What about this? This plus minus, because current is flowing downward. What is its value? I into 1. Now you touch the concept, you apply the touching concept, you touch positive first, plus 2.5 and touch negative minus I into 1, right? So equation 2. Substitute here I is equal to VAB, okay, or VAB is equal to I. Solving 1 and 2, then what do you get here? So I is equal to 2.5 minus I. So finally you got I is equal to, okay, 2I is equal to 2.5. Then I is equal to what? 1.25 ampere. Very simple problem. Okay. So this is how you can solve it. And I stop the session here, and in the next session I will discuss other problems. Okay. So all of you please quickly note down that. Quickly note down.